This is Algebra 1, Semester 1. It's a unit called Inequalities. It's the second unit. It's the second lesson within that called Writing and Graphing Inequalities. It's on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find it. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So to model that, I normally try to, because the notes are difficult to find, you guys. So let's see if I can manage this. There we go. So here's the website address, creatormath.weebly.com. Put that into the Google search, and it should bring up, if we're lucky, this home page here. Okay. If you have any questions about composition book, scroll down under the picture until you see the words composition book. Follow all of the directions here and go ahead and see all the videos. Follow those. And follow the turn-in dates and the instructions. Then we're going to go to notes. And if you're doing all that, you should have a 90 to 100% on your comp book. We're going to go to the content where this has got all the notes, the video lessons, the problem sets, and of course the vocabulary. So this is a PDF, Vocabulary Algebra 1 Practice Study PDF. This one is, this is a PDF with all of the vocabulary used for the entire school year. It is searchable, so download it to your device and then Google how do you search a PDF with whatever device you're using. It's a little bit different for all the different devices. So then you're going to find the semester you need. For this particular video, we're going to find semester 1. There it is. This is the table of contents for semester 1. You should have copied all of this, every line, into pages 2 through 6. This takes up about 3.5 pages, but it tells you where everything goes for the entire semester. We're now going to scroll down until we find the right unit. Here's a unit on inequalities. It's got 1, 2, 3, 4, 5, 6, 7 lessons. For each one, there's notes. This one's called, let's see, we're on number 2 here, Writing and Graphing Inequalities. That's this one here. So here are the page numbers that the notes will go on in your comp book. Please do not take this video's word for it, but go back and look at the original table of contents, because by the time you view this video, these page numbers probably will have changed. The notes are here in this link, then problems and the video solution will be here. So we're going to open the notes. Sometimes it takes me twice to open. Okay, that one loaded. And what you're able to do is enlarge it and take a look at the examples. Put these into your comp book. This talks about the number line, talks about if x is less than or equal to 6, how to graph that on a number line, whether we use a solid or open dot. Solid dot means inclusive of the value, so if it's less than or equal to, we have a solid dot. If there's no equals, then it would be open dot, because that means it's not equal to the actual value. Set notation is a little bit unusual for students, but we start it here in this grade level for Algebra 1, because in Algebra 2 you'll need it quite a bit. So set notation is a parentheses means the value is not included, which would be in the case of a negative infinity, because infinity is not a number, it's a concept, so you can't include it. And then a bracket would include the value. So if it's less than or equal to 6, solid dot means it's included, bracket means it's included in this set notation. In your mind, ignore the idea that you know what a coordinate location is with a parentheses and x comma y parentheses. This is a completely different notation. You can completely just shift your brain to say this is different. All right. Otherwise, it's going to confuse you. There's no value in remembering the coordinate location notation other than to say it's completely different than this. So if x is greater than or equal to -3, we're going to use a solid dot. We're going to go off to the right. Here, the bracket is around the -3 because it is included with the equals and the solid dot. And then the positive infinity goes off to the right. Again, it's a parentheses because infinity is not a number. You cannot use a bracket. Last example here, you'll put in your comp book. I think there's some other maybe on the other side, but the last one we'll talk about. If x is less than -2, it's an open circle because -2 is not included in the value. So this is going to go off to the left forever at negative infinity. And this is going to start at -2, which is not included. So a parentheses around the -2 and a parentheses around the negative infinity. Neither are included. Open dot says not included, and infinity can't be included. Here's solid dot, open dot, bracket, parentheses. Review those. Put those in your notes. And let's look at the actual problem set for this lesson. Given this, how's it read? This is greater than. Okay. If the larger side is to the left, we read from left to right. So as we encounter this symbol, the larger side's open, so that would be greater than. All right. How is this one? Symbol in red, and it's less than. As we go from left to right, we hit the smaller side first, so less than. Right? Review that and just get it back down. A lot of students know it before this class, but just review it and or learn it now. Given this one is greater than or equal to, so greater than or equal to. This one's less than or equal to. So these are very quick. They're just notation issues. On a number line, what does the open dot mean? The value is excluded. So here's a number line. Here's 0. Say we had a -3 and we had an open dot and everything going off to the right. So the open dot says the -3 is not included. So we could say x is greater than -3, because greater than -3 does not include that, but we cannot say greater than or equal to -3. This would be not true. You would need a solid dot to include an equals in it. Right? So the value is excluded if it's an open dot. Excluded means not included. On a number line, what does a solid dot mean? It means the value is included. So now we would use an equals. Equals, solid dot, both mean inclusion. When it comes to set notation, we have the same type of idea. Given a parentheses, it means the value is excluded, as in an open dot. Okay. And if we have a bracket, it means it is included, as in a solid dot. So once again, different symbols to show whether a value is included or not. How is this read? This is read positive infinity. So positive infinity means on a number line, everything to the right is going all the way up to positive infinity. Right? How far is that? It's forever, but it's always to the right. The opposite of positive infinity would be negative infinity. Right? So negative infinity means everything to the left forever, all the way down. Bigger and bigger negative numbers are actually smaller values. So I like, most teachers and books will not write positive infinity. They'll just write infinity, assuming everybody knows it's positive. And they do. But if I find that if I write a negative or a positive infinity, then students are expecting a negative infinity to show up. And I like that idea that they're getting ready for sort of that opposite. The opposite of positive infinity, I would say, is a negative infinity. So is infinity a number? No. Okay. Infinity is a concept that numbers either increase or decrease in the form of negative infinity forever. So if we're headed up to positive infinity, goes forever, negative infinity goes forever. It's not an actual number. You can't say a billion, because it's just a number on the way to wherever infinity is going, which is continuing to get bigger and bigger. You can't say 100 billion. That's not infinity, because infinity is a continuation to forever. All right? Given the following number line, how can we express what is being communicated in inequality and set notation? So here we go. This is -3, open dot, and off to the right. So we can say x is greater than -3, because x is everything including above the -3, but not including the -3, that's why it's greater than. In set notation, we would say the -3 is not included, so parentheses, comma, positive infinity, and parentheses because infinity is not a number, right? X is greater than -3, and parentheses -3, comma, positive infinity to show set notation. Again, exclude the idea of a coordinate location from your brain. This is a completely different concept. All right, now we got a solid dot at -3. So x is not only greater than -3, but also equal to -3. Now we're going to go from -3, bracket it because it's included, comma, positive infinity, because it goes all the way off to the right forever, and parentheses around the infinity because it's not a number. X is greater than or equal to -3. Bracket -3, positive infinity, parentheses. Given the following number line, how can we express what is being communicated in inequality and set notation? So, open dot, off to the left forever, and this is at a 2. So x is less than 2. It's not equal to because it's an open dot. Bracket negative infinity because, parentheses, negative infinity, comma, 2, parentheses because it's not included. So x is less than 2. Parentheses, negative infinity, comma, 2, parentheses. given the following. Okay, so solid dot at a 2, so x is less than or equal to 2. Now we get to say equals because it's a solid dot. Now we have a bracket 2 comma negative infinity parentheses. And notice I wrote it backwards because my brain is starting here and going down this way forever, right? So my brain starts here, bracket to 2, it's included, equals to, solid, or bracket. 3 ways to show the 2 is included. The negative infinity is not included with the parentheses because it's not a real number. I mean, it's not a number, it is a concept. Right, so x is less than or equal to positive 2, and parentheses negative infinity comma 2 bracket. All right, given the following number line, let's see, what do we got? All right, so up here, where is this? This is 5 and 10. This has got to be 6. So it looks like x is less than or equal to 6. Why has it got an equals? Because it's a solid dot. That means when I go and do 6, I need a bracket to include it. Included, included, equals means included, comma. It's going off to negative infinity forever. That's not a number, so I got to use a parentheses. So x is less than or equal to 6, parentheses, negative infinity, comma, 6, bracket. This one and this one. Given the following line, let's see what we got. We've got an open dot here. This is at negative 2. All right, so it looks like x is less than negative 2. We're going to have a parentheses negative 2, comma, negative infinity, parentheses. So x is less than negative 2, parentheses, negative infinity, comma, negative 2, parentheses. Right? All right, so make sure you're matching up the title of this video with the problem set you're doing. Otherwise, it's not going to help you much. So this is Algebra 1, Semester 1. It's the unit on inequalities, number 2. And it's the second lesson, writing and graphing inequalities. It's on creatormath.com under the Algebra 1 tab. Hope that helps.